In this hands-on, we'll explore the practical use of Lambda functions in Python and focus on 3 distinct applications as in prior hands-ons. Now, for the purpose of this hands-on, we've had to create certain dependency functions and data that will be consumed by the examples themselves as we lay them out shortly in this hands-on. Just to recap on what Lambda functions are, if you're arriving here directly and haven't seen the lecture before, they are also known as anonymous functions and are a key feature in Python that allows us to create small one-off functions without needing a formal function definition. And they're particularly useful in scenarios where the function is simple and need only be used once for what we're trying to achieve with our code. So let's go to our first example here on streaming log processing. In this code snippet, we have a function defined called streaming log processing example. And the core of this function is essentially a Lambda expression called format_log, which formats a log message. Lambda functions are ideal in this scenario because the formatting logic is concise and used only within this one function. And by using a Lambda here, we're keeping the code clean and focused and avoiding the need for a separate named function to perform that same activity. Moving on to the genome pattern recognition example, here we have a method where we use a Lambda function convert to RNA to convert DNA sequences to RNA. Again, the simplicity and single-use nature of this conversion makes it a perfect candidate for a Lambda function. The Lambda is simply replacing T with U in the DNA sequence, and as before, we didn't have to create a fully defined named function for this. We simply created a Lambda expression and assigned it to the variable convert to RNA in one single neat line. Let's now proceed over to stock price anomaly detection, where we've divided this example into 2. The first of these will use closing stock prices, and the second will use open, high, low, close prices. So our first example in this category demonstrates the use of Lambda functions to calculate the percentage change in stock prices. Here we have percentage change, a variable, which is a Lambda function that takes 2 arguments, the previous and the current price, and calculates the percentage change. This application, again, is showcasing that Lambda functions can be used for mathematical operations here that are fairly straightforward, but essential in this particular analysis of data, yet they don't need a fully defined named function to perform them. If we extend this example now to the open, high, low, close prices example, we're using 2 Lambda functions. So the method OHLC stock price anomaly detection example now contains 2 Lambda functions. The first of these is daily range, that essentially calculates the daily price range. And the second is the closing change, which computes the percentage change of the closing price from the opening price. By using 2 Lambda functions, we're replacing the need for having fully defined named functions. And secondly, they're effective in transforming the data in a readable and maintainable way, because should the calculation change to something else for whatever reason, we need only make those semantic or logical changes to the formula without having to write too much additional code. So in summary, Lambda functions, as you can see, are a powerful tool in Python, especially suited for situations requiring straightforward temporary functions, as we've demonstrated in this hands-on so far. Let's now continue to explore and apply these concepts in the upcoming lectures and hands-on sessions. See you there.